Supervised machine learning states that it is a type of machine learning in which machines are trained using well-labeled training data. And based on that data, machine will try to predict the output. The labeled data, that means the input is already tagged with a correct output first, such as, let's say, in exams, for preparing for the exams, we try to take a question and we try to prepare the answer for that question, right? So that input is tagged with that particular correct output or correct answer, that question is tagged with that correct answer. And then similarly, we keep preparing for the exam. So similarly, the input data is already tagged with the correct output. And when training comes, when the training data is provided to the machine, it will try to predict the output correctly, such as, let's say, we trained ourselves using those questions and answers during the exams, and now before the exams, and now during the exam only the questions were given, and under the supervision we have to write the answers to those questions, right, based on our previous training experiences. So that's how we are going to output for those questions. It applies the same concepts of students they learn under the supervision of a teacher. Its supervised machine learning is generally a process of providing input data as well as the correct output data to the machine learning model, and which aims to find a mapping function which will try to map the input variable X with an output variable Y. So for a given input or for a given input for that particular variable, the input which we have given, the machine will try to predict the outcome or output variable Y. Sometimes this is called as independent variable X, and Y is known as dependent variable on that particular input because it's a predicted output. How supervised machine learning works, right? How supervised learning works. In supervised learning, the models, they are trained using the label data sets, where the models, they learn about each type of data. Let's say in this particular figure, right? So different label data sets are given, such as, let's say, different types of shapes are given as an input, like square, rectangle, triangle, polygon, etc. Now, first step that we have to train the model for each shape, right? So now let's say if I take an example of a particular shape, let's say a square, it will have 4 equal sides, right? 4 sides, and all these sides, they are equal. That's my feature, that's my label, right? So here I will label that square will have 4 equal sides. Square will have 4 equal sides, and it will label that particular shape as a square. Similarly, if I take a triangle, it will have 3 sides. Then I'm going to label it, if there are 3 sides, then it's a triangle. Similarly, I can do it for 6 sides for a given hexagon, right? So these are my labels which are given to the input. So my model has the knowledge about the data. Now these are the labels, and this is the real data, right? So now I'll give the data as an input and the labels to the model. Now based on that, it will try that, okay, if the input is this kind of, and it will try to count the sides. It will say there are 6 sides, so it's going to be hexagon. If I give square as an input, it will try to compare or map here. It will say there are 4 sides, 4 equal sides, then it's going to be a square. Similarly, if I give a triangle, it will try to compare in these labels, and then it will say it's a triangle, and then it will say it's a triangle. Now after training, so that's my training phase. Now after training, we test our model using the test data set. So we give some sort of, let's say, percentage. Let's say out of 100% of data sets, we use 90% for training, 10% for testing. You can use 80% for training and 20% for testing also. So I am going to give my test input data, and then this time will not give, so this time using that previous experiences, it will try to identify that my test data set is a square or is a triangle, and higher accuracy, which means my model is trained and most likely it will predict the correct outcome. most likely it will predict the correct outcome. That's my basic flow of my supervised machine learning. That's the basic workflow of a supervised machine learning. In real world, supervised machine learning, they are often used in risk assessment, image classification, fraud detection, spam filtering, etc. These are the some of the applications of my supervised machine learning. The algorithms what we use for supervised machine learning, such as let's say decision tree, random forest, KNN, logistic regression, etc., they fall under the category of supervised machine learning. The major steps involved in supervised machine learning are: first, we have to determine the type of training data set. We have to determine the type of training data set. After that, we have to gather or collect the labeled training data. After that, we have to gather or collect the labeled training data. And then we have to split the training data set into we have to split the data set into training data set, test data set. Sometimes we use the validation data sets also, right? Let's say 80% for training data set, 10% for testing, and 10% for validation. Often we use just for training and testing. That is also okay, how we model it. Then the next step is to determine the input features, which is nothing but the knowledge about the data set, such as these labels, right? Such as this label, what we discussed. So determine the input features of training data set, which should have enough knowledge so that the model can accurately predict the outcome. Determine the suitable algorithm for the model. That means, such as, let's say, what we are going to use here, such as, let's say, support vector machine, decision tree, random forest, etc. Once the algorithm is identified, we can execute the algorithm on the training data set, and we have to evaluate the accuracy of the model by providing the test data. Now, let's say if the accuracy is 95% or 98%, that's a good accuracy. Now, out of 100, 98% of time, it's going to predict the outcome correctly, which means my model is accurate. So those are the basic steps. Those are the basic steps of my machine learning workflow or machine learning, how this supervised machine learning works. There are two types of supervised machine learning. Algorithms, such as, let's say, regression algorithms and classification algorithms. Regression algorithms, generally, they are used when there is a relationship between input variable and output variable. And generally, it is used for, there are two types of supervised machine learning algorithms, such as, let's say, regression and classification. And regression algorithms, they are generally used if there is a relationship between input variable and output variable. It is used for predicting the continuous variables. That means, let's say, your event is continuous, such as, let's say, weather forecasting, right? Temperature movements, they are continuous. Market trends, they are continuous. Let's say stock price movement, they are continuous, right? Every bits of time we got a particular price, and we know that that's how it's going to be moving further. There are some of the popular regression algorithms which we often use under supervised machine learning. That is a linear regression, regression trees, nonlinear regression, Bayesian learning regression, polynomial regression. There are some of classification algorithms are also available, such as, let's say, we apply these algorithms for identifying a categorical output, such as, let's say, yes or no, or 1 or 0 identification, or true or false kind of situation. Let's say a person is sick or he's not sick, or a person has a cancer or not, or maybe a person is male or female. That kind of outcomes we used to use. When we have that kind of tasks, we used to use the classification algorithms. Mainly, it is used for spam filtering. Right, and the algorithms what we use under that particular classification categories, like random forest, decision trees, logistic regression, support vector machines, etc. We will explore them. The advantages and disadvantages of the supervised machine learnings are, some of the advantages, such as, let's say, model can predict the output based on the prior experiences. So we need the experiences, we need the prior experiences in order to predict the correct outcome. In supervised machine learning, we can have an exact idea about the classes of the objects. We know that particular object belongs to a particular class through the labels, right? And in supervised machine learning, it will help us to solve various real world problems, such as, let's say, fraud detection, spam filtering. Based on a particular label, we can identify that that's a particular spam mail and then put it in the spam folder, right? Some of the disadvantages of supervised machine learning are such as, let's say, they are not suitable for handling the complex tasks. We will not be able to handle the complex task, extreme complex task using this. We need to apply some other sort of algorithms, such as, let's say, deep learning algorithms or something else. Supervised machine learning cannot predict the correct output if the test data is different from the training data. And if the model is trained on something else, and if the testing input data is something different, then it cannot predict it, because it's like labeled data set. It has to know the data sets and its features completely. Then and only then it will be able to identify. Otherwise, it will not be able to identify the training data set. Training requires a lot of computational time. It takes a lot of computation time. Time complexity is higher or larger in supervised machine learning. Um, we need to have enough knowledge about the classes of the objects. That means we need to know that each pattern of, or each feature of my particular data. I mean, most of the real time situations, we will not have that kind of knowledge about the objects. In that particular situation, supervised machine learning is not adequate.